Hi, this is Mrs. A of Mathematic. In today's video, you're going to learn about characterizing the roots of a quadratic equations using discriminant. Now, how are we going to determine the nature of the roots, or how we're going to characterize the roots of quadratic equations? In the quadratic formula, x is equal to negative b plus and minus square root of b squared minus 4ac all over 2a. The radicand here, b squared minus 4ac, is what we call the discriminant. Now, we can determine the nature of the roots by finding the discriminant of the equations. Now, here are the nature of the roots. If b squared minus 4ac is equal to 0, or if the discriminant is equal to 0, then the roots are real, rational, and equal. If b squared minus 4ac is greater than 0 and a perfect square, then the roots are real, rational, and not equal. If b squared minus 4ac is greater than 0 and not a perfect square, then the roots are irrational and not equal. If b squared minus 4ac is less than 0, then the roots are not real numbers. They are two imaginary solutions. Now, let's solve for the discriminant in order for us to determine the nature of the roots. I have here example number 1, x squared minus x minus 6 is equal to 0. First, you need to rearrange the quadratic equations in standard form, but this one is already in standard form. So what I'm going to do next is just determine the value of a, b, and c. So a is 1, b is negative 1, and c is equal to negative 6. And then substitute that in the discriminant, or b squared minus 4ac. So here, for b, that is negative 1 squared minus 4, a is 1, and c is negative 6. Then simplify. This is 1 plus 24, and that is equal to 25. So 25 is a perfect square. So here, for your reference, now, the result of the discriminant is equal to 25, which is greater than 0, at the same time, a perfect square. Therefore, the roots are real, rational, and not equal. Okay, let's have example number 2. 2x squared minus 8x plus 8 is equal to 0. Again, this is already in standard form, so we can find the value of a, b, and c. A is 2, b is negative 8, and c is equal to 8. And substitute in the formula, or the discriminant, that is negative 8 squared minus 4 times 2 times 8, the value of c. So perform this one first. Negative 8 times negative 8, that is 64, positive. And this one is negative 4 times 2, that is negative 8 times 8, that is negative 64. So 64 minus 64 is 0. So the value of the discriminant now is 0, which under this one, if b squared minus 4ac is equal to 0, then the roots are real, rational, and equal. Okay. Next, 2x squared plus 3x is equal to 8. This one is not in standard form yet, so we need to eliminate this 8 and move this to onto the left side of the equation, and this should be 0 here. So what are we going to do is add negative 8 on both sides of the equation. So this becomes 0. So what we have now is 2x squared plus 3x minus 8 is equal to 0. And then you can now find the value of a, b, and c. Then substitute the value of a, b, and c in the formula. And you have now 3 squared minus 4 times 2, the value of a, times negative 8, the value of c. So this is now 9, and this is negative 4 times 2, that is 8, times negative 8, that is positive 64, and that is equal to 73. Now, 73 is greater than 0, but not a perfect square. So again, since b squared minus 4ac is greater than 0 and not a perfect square, then the roots are real, irrational, and not equal. Okay, last one here. 3x squared plus 5x plus 4 is equal to 0. And then we can now find the value of a, b, and c because this is already in standard form. And substitute in the formula. So we have 5 squared minus 4 times 3 times 4. 5 squared is 25. 4 times 3 times 4, that is 48. And is equal to negative 23. Now, the discriminant is less than 0, negative number. So, since b squared minus 4ac is less than 0, then the roots are not real numbers. They are called imaginary numbers. Okay, so that's how you're going to determine the nature of the roots or characterizing the roots of quadratic equations. See you on the next one. Bye-bye.